Hello, this is Jesse Rogers, and I am going to show you how to do Python, programming in Python using what you know from college algebra. So you often are told that math is a really important skill. You're going to be using it in the real world for all kinds of applications, and one of those is programming, and that is true. And I'm going to show you in Python how if you know how to do college algebra, you can very quickly pick up some of the concepts in Python that are going to be very useful to you. What we're going to cover in this episode is going to be input, output, variables, functions, and conditionals. A couple other things too, but those are the main things that I wanted to talk about in this episode. So we're going to start with function notation. So you might have seen some equations like the quadratic equation y equals x squared plus 3x minus 4. Then there's another one that is an absolute value, y equals x minus 2. And then we have a linear equation because there's an understood one here as the exponent of 2x minus 5. So if it's a 2, that's a quadratic. If it's a 1, that's going to be linear. Um, so these are just three equations. They're all called y equals, right? So that gets kind of confusing. Which y are we talking about? When we have multiple equations like this that we're trying to incorporate into a problem, it can get really confusing really quickly. It's like naming all of your kids Bob. It's just not a great idea. So what we do instead in algebra is we name things f of x, g of x, h of x. What can be kind of confusing is that the notation we use here looks like multiplication. It looks like f times x, but that is not what's going on. We're using the same symbols for different meanings, just like we do in English. You know, we use the same words to mean different things sometimes. And yes, we are doing that here too. But it actually makes our life a lot easier because now we know which of these equations we're talking about. When I say g of x, you know that I'm talking about the one that has the absolute value. I'm not talking about this y, right? It's not y equals x squared plus 3x minus 4. I know that I'm talking about y equals absolute value of x minus 2 if I say g of x. And it also helps us keep track of what's been substituted into the x position. So that brings us to the next idea here, which is like, for example, if we're going to find f of 2, what that means is that everywhere that we see an x in the equation, that position of the variable is going to be replaced by whatever's in the parentheses here. So f of 2 means that we're just replacing all these x's with 2. So 2 squared is 4, plus 3 times 2 is 6, minus 4, that's going to give us 10 minus 4, which is 6. So f of 2 is equal to 6, and 2 is the x value, and that's also called the independent variable, the x value. And then 6 is the dependent variable. So the y value depends on the x value. So f of 2 is still a y value. Remember, we're just changing the name when we go to function notation. It is still a y value. The y value is 6. So the meaning here of f of 2 is equal to 6 really means the same thing as the coordinate 2 comma 6, because remember the x goes first, 2, and then 6. So that's the idea with function notation, and that's how it's used. And so now to go beyond the just initial idea of functions, one of the really cool things that you can do is you can compose more complicated functions that are bigger pieces composed of these smaller building blocks of functions. So an example of that, a simple one, is fog and goff. You have f of g. It could also be written like this: f of g of x. And for our purposes, I'm going to prefer writing it like this because that composition is much clearer to read in computer code. So f of g of x just means that we're replacing everywhere that we see it, the variable in the f equation, we're replacing it with what's inside the parentheses here. So this f of g of x is going to be replacing the x in the f equation with the entire g equation. So the absolute value of x minus 2 is getting put into each of those spots where you see the x in the f equation. So I color coded it to make it a little easier to see what's going on with that. Hopefully that makes sense to you, where we're inserting the g function into the f function. It's a really big idea. and it's no problem. Not very useful when we're just doing it like that, but we might have to compose much more complicated symphonies of equations. Again, using these really small building blocks, we might come up with really complicated functions, and those tend to be a lot more useful because we can do really intricate things with it, but it's also very hard to compute, right? So we can humans, no problem. When it's a little thing like this, big deal. We can handle that. But this, it's very easy to get lost in it. We're taking the G equation, we're plugging that into the H. We're taking the result of that, we're plugging it into the F. We're taking the result of that, plugging it into the H. And it just gets really, really complex. You're not going to be able to do those in your head. And what about if you have to find every value of X from 1 to 20? So you can see how these get really tedious really quickly. Back in the 1950s, before we had computers as machines, there used to be humans that did these kinds of calculations. That hasn't existed for our entire lifetime, probably your parents' lifetime. It's not something that humans do anymore. What we do is we program computers to do all this nonsense for us. And so that is what I'm going to show you how to do next. We're going to use the Python program here. I just did Python online compiler because I don't want to have to download anything. I want to just show you in the browser what we're going to do. So we're going to use an IDE, which is an integrated developer environment. I'm going to use this www.online-python.com. This is the one I like to use. You can change the settings, whether it's day or night. I like the night theme. Personally, I think it's a little easier for me to read the text. So what we're going to do is get rid of all this initial text that we start with. Oh, we got ads coming. I'm sorry about that. There we go. Okay, we're done with that. Okay, so I'm going to take these functions here, and we're going to copy these directly into Python, and this is where we put our code. This is where we run it and see what the computer does with that code. So that's what's meant by an IDE, that development environment. So we're just going to go ahead and run this and see what happens. Obviously, it's not in the language of Python yet. So the computer looks at this and it's like, what are you doing? I don't know what this means. So it can't handle it in its raw math form directly from this function notation. It doesn't know how to handle that. But we can very easily and quickly translate this into Python. So that's what I'm going to do. I'm going to do DEF. And what that does is it says, hey, Python, I am defining a function. It's going to be a function called f, and it's going to take a variable called x. And then there's instead of an equal sign, you have like these colons here. So define f of x, and we're going to use another keyword called return. So it's going to we're defining the function f, it's taking the variable x, and what it's going to return is x squared plus 3x minus 4. But we actually have to translate this too, because it's not x squared right now, it's just x2. So how do we get it to be squared? Well, you might think, let me use the caret, but that actually means something else in Python. That's a different function. So what we're going to do is star star. Star star is the way that you do exponents in Python. So this means x squared. And it doesn't know what 3x means. We have to tell it explicitly this is the number 3 times the variable x. So now it knows, okay, because we put a star in between there, it knows that means multiplication. So you have to be very explicit when you're doing computer programming. You have to tell it exactly what you mean. It's not going to have any forgiveness with its syntax. If there's any mistakes in there, it's going to say, I don't know what this means, and it's going to return an error. So we're going to define this other function. Remember that means we're going to have to put the colon, and I'm going to get rid of these bars here, and I'm going to return instead what's called ABS, absolute value. So absolute value, and then whatever I want to take the absolute value of is going to be in parentheses. So the absolute value of x minus 2 means the same thing as what it means mathematically here with those lines. So the absolute value of x minus 2, now it knows what to do with that. And I just have one more function that I'm going to define. So this is going to be define h of x as return. So it's going to return me the value of 2x, 2 times x minus 5. Okay, so now I'm going to run it and let's see what happens. Okay, so it did not give me any errors, but it also didn't do anything because I didn't tell it to do anything, right? I defined 3 functions and the computer says, okay, cool. And that's it, right? So if I want it to do something, then I have to do input output kind of commands so that it engages with the user. So I'm going to start with print, and instead of actually using these functions, I'm going to do a tried and true tradition here of printing hello world. That's the first thing we do when we have a new language when we're first starting. So I'm going to put print, put it in parentheses, and I'm putting hello world in quotation marks to tell the computer that it's a string. So I'm going to click run and it prints hello world. Congratulations. If you did this, you're a programmer, right? That's all it takes. Now you have told the computer to do something, it did it. All right. It's a very, very empowering kind of feeling when you can make a program run. So even if it's a simple one like this, let's get off to a good start. So print hello world. And we didn't call any of these functions, but it did do a printing of the hello world string. All right, so now we're going to do something a little more um, to the point of what we've been working on. So I wanted to print f of 2. Remember that we were doing that before. We were saying that the f of 2, if you recall, that was right over here. We're replacing x with 2. And so f of 2 should equal 6. So now I'm going to run this, and I want it to print f of 2, run it, and it gives me a 6. So instead of me having to compute that by hand or in my head, the computer did that for me. So we can take this to some crazy extremes now. So you remember this a pile of what can we say? This is just a ton of different functions, right? Composed here. So we have a whole symphony of composite functions. So let's see if it will do this. And I'm going to replace the value of x. Let's give it a 2. We'll say it's a 2. And I think we need an extra set of parentheses possibly because, yeah, I have a print statement that has to be closed with an extra set of parentheses. So now I'm going to run this. And it took a second, but it actually did compute me the value of 14. It did that a lot faster than I would have, right? So if I had to take that 2, plug it into the G function, get my answer. Then take that value, plug it into the H function, get my answer. Then take that, plug it into the F function, get my answer. Then take that. I mean, that takes a long time. Humans do not want to do that. And so it's so much better to just get Python to do it, just get computers to do it. And so that's one of the applications of how you would do this stuff. And how you would create composite functions. Now, this is what's called hard-coded. It's only going to be able to handle whatever value I put in here, and I, as the programmer, am putting in a value, but the user doesn't have any option. It just displays a 14 here, and that's all it displays. So maybe what I could do is have a little bit more flexibility for the user. So I could print or let's get rid of this for now. And what I'm going to do is I'm going to use another command called input. So I'm going to have input gather get a command from the user. And so I'm going to say, please enter a value to evaluate in f of x. So this is again called a string, right? And that's just like a phrase. It's a list of characters. So these don't have any mathematical value to them that can be evaluated. It's really just it tells the computer what to display on a screen. So I'm going to run this. It says, please enter a value to evaluate in f of x. That's probably please enter a value for, let's say, for f of x. That sounds a little less redundant or a little whatever. I don't know. So please enter a value for f of x. So I'm going to put in 2 again. And it says, cool. Okay, didn't do anything. It took the value of 2, but it didn't put it anywhere. So what we need to do is we need to store this as a variable. So I'm going to put x equals input, and then it's going to do that for me. So I'm going to run this. Enter a value of 2. Okay, it stored it, but it still didn't display it, right? So what else do I need to do? So I need to have this print f of x. Okay, get ready for this. Enter a value for f of x. Oh, it gives me an error. Why does it give me an error? Well, because in programming languages, you have a lot of different data types. You have what's called Boolean data types, true and false. That's like the simplest kind of uh, uh, concept. Something's either 0 or 1, true or false. And then you have another data type that's integer. That could be anything from like -2, 0, 5, 7. Those are integers. Then you have float in Python. Those can include decimals. Then you have strings. There's a couple different data types, and you can only do things with the data type that are allowed for that data type. So when I take a string, um, and that's what the input function would normally handle. It's going to take whatever the user puts in, it's going to handle it as a string. So if I'm taking a string and I'm putting that into X, and then I tell it, okay, now take that X and put it into the function here, then the problem with that is that it's taking a phrase and it's trying to use it like a number. And that doesn't make sense. The computer doesn't know how to do that. So what we have to do is we have to give it the int keyword. So that tells the computer that what it's going to do is get some value from the user using the input, and then it's going to take that value and turn it into an integer, and then that's going to get stored as X. So let's run this again. Let's see if it works now. So now it'll work, right? So now it'll take the 2 that I enter, and it's not storing it as a string. It's not storing it as a character. It's storing it as a number. And so it can now be manipulated as if it is a number, as if it's an integer. So I'm still relying on the user to do this properly. So for example, let's say that I enter in 2 as as I'm still going to get problems. And we're not going to go into all the debugging of how to make this user proof in our in this episode. We're just going to kind of cover some of the basics, but there are ways that you can handle this to either have the user continually enter until they get it to be something that you can actually use, or um, uh, you know, or give you some sort of kinder error message that says, "I'm sorry, user, I really need a number," something like that. So anyway, for now, let's just imagine that our user is only ever going to enter in correct things. So we're gonna print this. And it is just going to be for the f of x function. And we could make this a little bit nicer. We could say print, and we'll put in the parentheses the value of y when, or the value of f of x, which is a y value, but the value of x when x is, and then we'll put a comma x, the value of f of x when x is f of x. Okay, so I think I've got maybe too many parentheses in there. Let's see. That is as many parentheses as I need. Okay, so the value of f of x when x is f of x. Let's see. Let's run this and see if it works. So I'm going to put 2, and now it says the value of f of x when x is 2 is 6. So we could put is, or we could put equals. Maybe we like that better. I don't know. The value of f of x when x is 2 equals 6. So you can play with, exactly how you would want to allow that to display. And, that's a big part of programming, is just making that interface user friendly. There are tons of modules in Python that allow you to do artificial intelligence, machine learning. You can make games in it. You can create windows, do web applications. You can do all kinds of stuff in Python. But this is just the simplest user interface here on an online Python compiler that just interprets what you're seeing on what you're writing in here. It turns it into machine language, and then it evaluates it. And that's a very simple kind of introduction to Python. Obviously, like I said, you can do so much more with this, but it leads directly out of what you learn in math class, and you can utilize um, the the kind of techniques and the kind of uh, way of thinking that you learn from college algebra, and you can just very easily translate that into Python code once you have just a little bit of familiarity with it. And I realize that probably this looks still pretty foreign to you, and if you were to try to do this by yourself, it might be a little bit challenging. But hopefully we're off to a good start here. So I'm gonna do one more concept and then we're gonna finish it out. So this is conditionals, and so we have function notation where we're gonna basically be doing this would be a larger bracket in the textbook, but basically what you're doing is you're using this function. This is all now part of one function, one singular function, rather than broken up into three separate functions. But each of these is only active during a certain interval. So if x is less than 3, this is the function we're going to be using. If x is between 3 and 8, this is the function we're going to be using. And if x is greater than 8, then this is the function we're going to be using. So we want to take this logic here, and we want to put that into Python. So I'm gonna go ahead and I'll keep this actually. If you want to comment things out, if you don't need them, you can use the hashtag and it comments out whatever it is that you have there, basically meaning that it's not going to be used. It's only for human reading. It's not actually including that in the computation itself. So that's how you can like just sort of quickly edit things out. If you're not sure if you're going to need it again and you don't want to completely get rid of it, you can always comment things out. So I'm going to go ahead now and put in uh, that little phrasing here. So f of x is this. Now, obviously, I'm not going to be able to utilize it in this form, but it sort of gives me um, a little map of what I'm doing. So what I'm going to have Python do is let's move this print statement. I'm going to copy this over to down here. Oops, I got rid of it. That's all right. We can print it again. So what we're going to do is make this a conditional. So now we have the variable x, right? So the user has input a value, we've turned it into an integer, and now we can do some manipulation with that x. So if x is, actually, I'm going to use it straight from the math. So copy this. If x is less than 3, then here's what you do, computer. You're going to print f of x. Yeah, we want it to print f of x. What about if x is between 3 and 8? I'm going to have it, I put a colon there, and here's what I want you to do, computer. I want you to print f of, no, I want you to put g of x, because remember that the g function, where it's the absolute value, that's the one I want it to call if x is between 3 and x, or 3 and 8. And then if x is greater than 8, then I want it to call the h function, right? So that's going to be if, and I'm going to just copy it here again directly from the math translation. So there's really no translation needed to be done. We just put a colon at the end of it and then print h of x. So I'm going to get rid of this now because that won't be recognized by the computer, but this will. So I'm going to go ahead and run this now. Oh, I have too many ifs. Okay, if x is 2, okay, so it's going to call the f function if x is less than 3, so that worked. And then let's do it again for maybe a value like 5. Let's take a value of 5. So the absolute value of 5 minus 2 would be 3. and absolute value keeps a positive value positive. So it should give us 3 when I enter in an x value of 5, and it does. So that worked. And then let's try one more. So I'm going to run this. And what if it is greater than 8? So let's say 10. So 2 times 10, that's going to be 20, minus 5, that's going to be 15. So let's enter a value of x for 15, and it gave us 25. How did it give us 25? So we're returning 2 times 10. Did I say 10? Sorry, I got distracted. Let me try this again. Enter a value. We're going to enter in 10, and it gave us 15. Okay, I entered in 20. Sorry about that. Okay. All right. So that just underscores user error, doing things in our head, not great. The computer will always do exactly what you tell it to do, which is very nice. So it protects us from ourselves. I make lots of mistakes. I'm sure everybody does. And those little mistakes, the computer's not going to do it. It's going to do exactly what you tell it to do. So that is one of the things I really love about computers. And hopefully that gives you uh, a little bit of a brief introduction to this. So we can comment, this is defining functions. That's what we did there. And let's put a comment here for obtaining input from user. That's what we did with that. And then down here, what did we do? We applied conditional rules to tell us what function to display. So that's pretty much it. That's our conversion of a piecewise function into translating it into a Python code. So hopefully you guys enjoyed this. Let me know in the comments if you have more questions that you want me to go over, anything in algebra or calculus or statistics. Like there's lots of cool stuff you can do with Python. There's packages that have just all kinds of functionality to them. I didn't get into any of that with this introduction because I just wanted to give you the very basic rules. But let me know what you guys want next, and I'll try to make sure to show you. All right, Jesse Rogers out. I'll see you guys next time.